The need to increase utilisation of aerodromes that handle IFR traffic in IMC can be met by the use of parallel or near-parallel runways. An aerodrome already having dual parallel precision approach ILS or MLS runways could increase its capacity if these runways could safely be operated simultaneously and independently in IMC. There are three main types of operation associated with parallel or near-parallel runways. The first is the simultaneous parallel instrument approach, of which there are two basic modes of operation. Mode 1 is when independent parallel approaches are made, where the radar separation minima between two aircraft using adjacent ILS and/or MLS is not applied, and Mode 2 is when dependent parallel approaches are made to parallel runways, where radar separation minima between aircraft using adjacent ILS and/or MLS systems are applied. The second is the simultaneous instrument departure, which has one mode of operation, Mode 3. This is when independent parallel departures take place for aeroplanes simultaneously departing in the same direction from parallel runways. The third, segregated parallel approaches and departures, has one mode of operation, known as Mode 4. This allows for one runway to be used for approaches and the other for departures. Semi-mixed operations from parallel runways take place when combinations of the above modes of operation take place. The normal operating zone is defined as the airspace of defined dimensions extending either side of an ILS localizer course and/or an MLS final approach track centerline. Only the inner half of the normal operating zone is taken into account in independent parallel approaches. The no transgression zone is the corridor of airspace of defined dimensions located centrally between the two extended runway centerlines, where penetration by an aeroplane requires a controlled intervention to maneuver any threatened aircraft on the adjacent approach. It extends from the closer threshold to the point at which 1,000 feet of vertical separation between the parallel approaches ceases. On the diagram, this extent is abeam the red triangle, which indicates where the southernmost aircraft will descend below 3,500 feet and thereby end the vertical separation between the aircraft. To conduct parallel approaches, aeroplanes must be fitted with the normal IFR avionics, including full ILS or MLS capability. Where independent procedures are in force, all aircraft are to be advised accordingly on initial contact with approach control. Regardless of weather conditions, all approaches are to be radar monitored by radar controllers specifically dedicated to that role, using a dedicated radio frequency. Each pair of parallel approaches will have a high side and a low side to provide vertical separation until aircraft are established inbound on the ILS localizer course or MLS final approach track. The high side will be 1,000 feet above the low side, and controllers will direct aircraft that deviate significantly from their approaches. If aircraft fail to take corrective action and penetrate the no transgression zone, the aircraft on the adjacent ILS or MLS will be issued appropriate control instructions, maybe even an overshoot order. Simultaneous parallel ILS or MLS operations require diverging tracks for missed approaches and departures. Turns to achieve divergence are to be initiated by pilots as soon as possible. When building runways for simultaneous parallel use, minimum spacing distances between the landing or takeoff surfaces are defined and illustrated here.